So here we have the same base with exponents. So we're going, since we're dividing, we subtract the exponents. So we'll take the top and subtract the exponent from the denominator. You can distribute that negative. So we get 4p minus p when we combine like terms. So that's 3p. And then a positive q and another positive q is 2q. So that's our exponent. The base of both of those was a, so you keep it. And that's your answer. Now, since we have powers to a power, you distribute the exponents and you're multiplying. So it's a to the 2p and b to the 2q. And we'll do the same idea here. So that's a to the negative 3p, b to the negative times negative makes positive 1q. Now we can combine to multiplication. So we would add exponents for the 2p and the negative 3p. Keep the base, you get negative p. And then b to the 2q and 1q, that's 3q. And then the only thing that's left that we can do is move the negative exponent. So we can keep the b to the 3q in the numerator, and then a to the positive p if we move it to the denominator. So when you're simplifying a problem like this, you want to break it down all to their prime numbers. So 2 is prime, so that's okay. 81 is not prime. We'll break that down to, you can think of it as 9 and 9, but that's really just 3 to the 4th. So call that 3 to the 4th. 6 is 2 times 3, so that's to the 11th power, so they both get the 11th power. So now, mentally, I'm just going to combine our two 3 to the 4th and 3 to the 11th. That's 3 to the 15th. So when I combine all of our 3's, we have 3 to the 13th up top, 3 to the 15th in the denominator. You're subtracting exponents, so that means we'd be left with 3, 13, and 15. We're going to have 2 left over in the denominator. And then we have 2 to the 10th, 2 to the 11th. So it's going to be a 2 to the 1st left over in the denominator. Since there's nothing left in the numerator, put a 1. That's 2 times 9, so it's 1 over 18. So here we have a power raised to a power again. So we will distribute the exponents. We're going to multiply those, but the 5 is out in front, so that does not get the exponent. So multiply our exponents, you get 6. Multiply our exponents, we get negative 8. And we can move that negative exponent to the denominator. There's our final answer. This one's a little bit tricky, just the way it looks. But since it's a negative exponent, that really means it's 1 over 4 squared and 1 over 4 to the 1st power. So you can think of that as 1 over 16 and 1 over 4. Since we're trying to add fractions, we need common denominator, so multiply. Make that be 4/16. So now when we add, we get 5 over 16. Here's another problem where we have the same base, so we will be adding exponents. Multiplication means we add exponents, so we have p minus q plus q plus p minus 1. So we're really just adding like terms. We have p plus p is 2p. A negative q and a positive q is 0, and then minus 1. So this is what we get when we add like terms. So that's our exponent, and the 3 is our base. Here we have a division problem. The bases are the same, so we will subtract exponents. We take 7 away from the 8. We have 1 left over in the denominator. The base was the same, so you keep it, and then the power would just be 1. You could write it without the parentheses, just like that. Here we have the same bases again, so we will add exponents. This one's a little bit tricky because the exponents have different denominators, so let's make them have the same denominator so we can add. So 1/2, you can think of that as being the same as 2/4, and now they have a common denominator. So you keep the base, add the exponents, 3/4 plus 2/4, 5/4. Rationalizing the denominator. So we have 2 parts to this, so we're going to handle them a little bit separate to begin with. Square root of 48. If you factor down 48, that is 4 times 12, 4 times 3. So there's a perfect square in there. So if you simplify this, this is 4 square root of 3. And then we have 5 over the square root of 3. We need to rationalize that denominator. So we will do that by making this be, since that's a square root, make it be a perfect square. So we'll multiply by another 3, square root of 3, so that way we get 9 in the radicand. And then square root of 9, of course, is 3. And then the numerator, we have 5 times the square root of 3. And we need to simplify this a little bit further. We need to add these 2 terms together. In order to do that, they have to have a common denominator. So this needs a 3 in the denominator, which means we would have to change the 4 to a 12. 12 divided by 3 is 4. So it's the same, still equivalent. So now they have a common denominator. There's our 3. 12 square root of 3 plus 5 square root of 3. 17 square root of 3. Again, we're rationalizing the denominator, so our denominator needs to be a perfect square. So we can make this become a 9x squared by multiplying by another 3x inside the square root. So that becomes 9x squared inside, which of course is a perfect square. That's what we were going for. Just be 3x. Then our numerator, we can multiply the radicands together. 3 times 4 is 12, and then x y squared. Then, of course, we have 12 here. We could simplify that. We could have simplified it at the beginning. We know the square root of 4 is 2. So if you simplify that 12, it would be 2 square root of 3. And then the x y squared, of course, is a perfect square also. So that also would leave the square root. And as I mentioned, you could have done it at the beginning. The numerator just would have been 2y. And then you multiply by the square root of 3x. And that's, of course, the same thing we got. Rationalize the denominator again. So this, since this is has an index of 3, this needs to be a perfect cube inside. So perfect cube, we can make that become a 27, which of course is 3 cubed. So if you make that a 27, we have to multiply by 3. So we'll multiply by the cube root of 3. And then 5 cube root of 3 in the numerator. And the cube root of 27, as we mentioned, is 3. Now it's rationalized. When there's addition or subtraction in the denominator with a square root, you will rationalize by multiplying by the conjugate. So we keep the exact same two terms. Except we change the sign between them from plus to minus. Now we will multiply that out. Distribute the 3. And then the denominator we have to FOIL, but anytime we're multiplying out conjugates, there's a bit of a shortcut because the outside and inside is always going to cancel. So you just have to multiply the first terms, square root times square root. Just be a regular 5. It would be square root of 25, which is regular 5. And then positive 2 times negative 2 is negative 4. So our denominator is 1. So we don't even need to write it. So here we have another where we're trying to add fractions with square roots. So they need to have the same index, the same radicand, 2 and 2, and the same denominator. So we need to make a denominator of 2 so we can add these fractions. So that would have to be 8 over 2. But now we can add, we have the same square root of 2, same denominator, so 1 plus 8 is 9, square root of 2, all over 2. Here's another problem with, this time it's subtraction in the denominator. So we're going to have to multiply by the conjugate again. So it'll be square root of x plus y. Just change the sign in the middle. And multiply the same thing to the numerator and denominator. So distribute the numerator, x times square root of x plus y. X times y. And then our denominator, again, remember the shortcut. You just have to multiply square root of x times square root of x. It's just x. And then negative y times positive y is negative y squared. Another problem we can simplify by multiplying by the conjugate. We'll rationalize the denominator. So the conjugate, we have to change the plus to a minus. Distribute the numerator again, so 5 square root of x. And then square root of x times square root of x will just be x. And our denominator, 5 times 5 is 25. Positive times negative, square root of x times square root of x is x. This time it's a fourth root, so we need a perfect fourth power in the denominator to rationalize it. So since we have a c to the third power, if we just had one more c inside the square root, or inside the fourth root, then we would have a perfect fourth power. So as long as we multiply it to the denominator and the numerator, it'll work out. So our denominator now is c to the fourth, and the fourth root of a fourth power is just c. And then our numerator, we have the fourth root of 16, which is just 2. The fourth root of a to the 8th, just think of that as a fraction, 8 divided by 4, so that's going to be a squared. And then, of course, that c, it's only its first power, so that cannot come out of the radical. So our numerator is 2a squared times the fourth root of c.